Assalamualaikum and hi everyone, my lovely student. This is chapter 2, Matrices from 5, part 4. So our learning standard for this video, multiply two matrices. So how to multiply two matrices? So based on the previous situation, the sale of fan in the month of March can be represented with a matrix as follows. So this is the matrix P. So the commission for selling each unit of the stand fan, selling fan and wall fan are 25 ringgit, 30 ringgit and 20 ringgit respectively. How do you calculate the total commission earned from the in-store and online sales? So total commission earned from the in-store sale 16 times 25 ringgit plus 18 for selling a fan times 30 ringgit plus 11 times 20 ringgit is equals to 1,160. Total commission earned from the online sale. So this is for online sale. 5 times 25. Let me use laser pointer. Okay. Plus 10 times 30 ringgit plus 4 times 20 ringgit is equals to 505 ringgit. So the total commission earned can be calculated in the form of a matrix. If the commission of selling each unit of the fan is represented in the form of column matrix, that is, so this is the commission, then the total commission earned from the in-store and online sale can be written in the form of matrix as follows. So this is metric for in-store and online sale. This is the metric of the commission. So 16 times 25. So let me explain this first using my pen. Okay. So as you can see, this is 2 by 3 2 by 3 metric. Okay. The order of this metric is 3 by 1. So this metric can be multiplied because here got the same value. So you will get the answer of 2 by 1 metric. That's why the answer is 2 by 1 metric. So for the first row, multiplied with the first column of this matrix. Oh, sorry. Sorry for the not straight line here. Okay, that's why 16 times 25 plus 18 times 30 plus 11 times 20. So do the same thing for the second row. Second row multiplied with this column. So you will get this. So PK is known as the multiplication of matrix P with matrix K, and this matrix is the product of the two matrices. In general, to multiply two matrices A and B, the number of columns in matrix A must be the same with the number of rows in matrix B. So this is very important. The number of columns in matrix A must be the same with the number of rows in matrix B. The number of rows in matrix A and the number of columns in matrix B become the order of the product of the two matrices AB, like what I'm doing just now. So the first matrix is 2 by 3 matrix. The second matrix is 3 by 1 matrix. So the sentence just now, the number of columns in matrix A must be the same with the number of rows in matrix B. That's mean here the number of columns in matrix A. So the first metric, we call it as metric A. The second metric, we call it as metric B. So the number of column in metric A must be the same as the number of row in metric B. So that's the mean of the sentence. This number of column in metric A must be the same with the number of row in metric B. So this is very important, so that you can multiply the two matrices. If the number of column in metric A not the same with the number of row in metric B, then multiplication cannot be performed. So if the number of column is equals for metric A is equals to number of row in metric B, then you can multiply these two metric, and for this sentence, the number of row in metric A and the number of column in metric B become the order. So the number of row, I've used the different color of my pen, so that is easier for you to see. So the number of row in metric A, okay, this one, the number of row in metric A and the number of column in metric B. So this is the number of column in metric B. So the number of row in metric A and the number of column in metric B become the order of the product of the two matrices. That's why the answer in the form of 2 by 1 matrix. So the number of row in the first matrix or the A matrix and the number of column in B matrix become the order of the product of the two matrices. Okay, so this is basically what I'm saying just now. This is the order of metric A, which is m times n, and then this is the order of metric B, which is n times n. Okay, here n must be the same number. So number of column in A equals to number of rows in B. So when these two numbers are equal, then the order of metric A times B is m times P, or m by P. M by P. I hope you understand this. Okay, if metric A has an order of m times n and metric B has an order of n by P, then the multiplication AB can be performed, and the order of B is m by P. Okay. Next, have a look at this example. Example 15. It is given that matrix C is 8, 3 and matrix D. Determine whether multiplication CD and DC can be performed. If yes, state the order of the product of the matrices. First, you have to identify the order of matrix C and D. So for the first one is for CD. Order of matrix C is 2 by 1. Order of matrix D is 2 by 2. So as you can see, the number of column in matrix C and the number of rows in matrix D not the same. So multiplication CD cannot be performed because the number of column in matrix C is not the same with the number of rows in matrix D. Okay, so for DC, okay, this is the order of matrix D, which is 2 by 2, and this is the order of matrix C, which is 2 by 1. So as you can see, these two values are equal. So multiplication DC can be performed because the number of columns in matrix D is same with the number of rows in matrix C. So the order of DC is 2 by 1. Okay. Next. Example 16. It is given that matrix A, this is matrix A, and matrix B. Calculate AB. Okay. So this is the solution. Okay, for the first, you have to identify first the order of this matrix. So this is 2 by 2 matrix, and this is also 2 by 2 matrix. These two numbers are equal. Then these two can be the multiplication can be performed, and the order of the answer is 2 by 2. Okay, how to multiply these two matrices? Okay, this is the step. First row of the first matrix, look at this green color. First row of the first matrix multiplied with first column of the second matrix. Okay, then 2 times 6 and then plus 3 times negative 2. Okay, so this is for the first row, first column of the answer. So this one, you can use your calculator, you'll get 6. Okay, 2 times 6, 12, plus 3 times negative 2 is negative 6. So 12 minus 6 is 6. So this is the element at row 1 and column 1. So for the second, first row, second column. So first row of the matrix A times with second column, the blue color here, of matrix B. So 2 times negative 7 plus 3 times 1. So you calculate this, you will get negative 11. Next, for the second row, first column. So take the second row of the first matrix times with first column of the second matrix. Okay, so 1 times 6 plus 5 times negative 2. So when you calculate this, you will get this answer. Next, for the last element here, second row of first matrix times with second column of the second matrix. So 1 times negative 7 plus 5 times 1. As you can see, for the first matrix, we just use the row. Okay, the row. And for the second matrix, we just use the column. Alright. So this is the final answer when you multiply these two matrices. Okay. So this is the answer. Example 7, it is given that matrix E, this is matrix E, and matrix F. Also given matrix G. Calculate GE, means matrix G times matrix E. So this is matrix G, and this is matrix E. So for matrix G is 1 by 2 matrix, and for matrix G is 2 by 3 matrix. So here the same value or the same number, so that multiplication can be performed, and this is the answer or the product of matrix. So the final answer will be in the form of 1 by 3 matrix. So remember just now I said for the first matrix, just use the row, and for the second matrix, we just use the column. So I'll use different color of pen so that it's easier for you to see. So the first row for the first matrix here, you multiply with the first column of the E matrix. So 4 times 5 plus. This one also always plus, okay? 3 times negative 4. So this is for element. This is the element for first row, first column. Next, for the first row, second column, this row multiplied with second column of the E matrix. So 4 times negative 1 plus 3 times 8. 4 times with negative 1. Remember, plus 3 times 8. Okay, so this is for first row, second column. For the first row, third column, okay, so the first row of G matrix multiplied with the third row of the matrix the third column of matrix E. So this is answer for first row, third column of the answer. So you just calculate all these three and then you'll get the answer. Okay, I hope you understand this so that we can go faster after this. So for B, F, G, so we know that the answer will be 2 by 2 matrix. So remember, for the first column, just use the row. And for the second column, for the second matrix, use the column. So negative 2 times 4. So this is the answer for first element. So for this, the first row times with second column. Okay. Still in first row, but this time multiplied with second column of the G matrix. Okay, for this one, okay, for second row time with first column. Next, second row time with second column. So I really hope you understand. So for GF, so this is 1 by 2 matrix and F is 2 by 1 matrix. So our answer will be 1 by 1 matrix. So just remember, just use row for the first column and column for the first matrix and column for the second matrix. So first column time with first row time with first column. Alright, so you'll get only 1 by 1, so only one element in this matrix. For example 18, it is given that matrix K, so this is matrix K, and matrix L, calculate L square. L square means L times L. So this is matrix L, this is matrix L. Use the same method that I showed just now. Remember, please remember, row column. Row, column. Okay. So this is the answer for A. For B, KL square. So first, this is K. This is the matrix K. L square, just now you just take the answer in A. So remember, row times column, row times column. Okay. And for C, L cube. So the answer in A just now, you time with a matrix L. Okay, so this is the answer. Next, example 19. Given that this is metric and with a metric is equals to this metric, calculate the values of x and y. So, first, this is the question. Next, you just multiply. Okay, wait. Okay, I will use this color purple. Alright. So, this is the row of the first matrix time with the first column of the second matrix. So here 6x times 2, 6x times 2 plus negative 5 times 1. So this is for the first element. Okay, and this is for the second element. The first row, now you multiply with the second column. So that you will get this. Then this matrix equals to this matrix. Okay, so that compare the corresponding element. So 12x minus 5 is equals to 7. So that you'll get x equals to 1. 18x minus 20 equals to 1 minus y. So you just calculate this. Substitute the value of x that you get here. So you'll get the value of y. Example 20. The table below shows the share unit purchased by Khairil and Mahmud. So this is the table. It is given that the price of 1 unit of share A and 1 unit for share B during the purchase are RM 1 ringgit 50 cent and 82 cent respectively. Calculate the total investment of Khairil and the total investment of Mahmud. So this is the shares that purchased by Khairil and Mahmud. So this is the price of the 1 unit. So you just remember this is row times column. So you get this. So this is the answer. So the total investment of Khairil and Mahmud are 10,780 and 7,920 respectively. So this is your homework. Self-practice 2.2c. So this is all the question of self-practice 2.2c. Altogether, you have 6 questions. Thank you for now and see you in the next video.